Hey everyone, Linus here. Today we're diving into the world of fintech, specifically how mainframe DB2 database migrations to Snowflake actually work. At the heart of it all are these robust mainframe databases. These systems are like the tireless worker bees of the financial world, constantly buzzing with activity. Mainframe DB2 databases have been the backbone of financial institutions for decades. They handle all those crucial real-time transactions you make, like depositing your hard-earned cash or checking your balance. Think of it like this. You open your financial app and decide to move some money around. That request goes all the way to a massive data center, where your mainframe DB2 database swings into action. It verifies your information, updates your balance, and makes sure everything is hunky-dory. This happens in the blink of an eye, all thanks to the power of these mainframe DB2 databases. But here's the thing, these databases aren't just about individual transactions. They hold the entire history of your financial account, every deposit, every withdrawal, every interest payment. It's a treasure trove of data that needs to be accurate, secure, and always available. That's why migrating these databases to Snowflake is a big deal. It's like moving a library while people are still trying to check out books. It requires careful planning, meticulous execution, and a whole lot of technical know-how. Now, let's take a step back and think about the sheer scale of these operations. We're talking about data centers that span football fields, filled with thousands of servers. Each server is a critical piece of the puzzle, ensuring that your transactions are processed smoothly and efficiently. And it's not just about processing transactions. These systems also provide valuable insights. Financial institutions use this data to understand trends, manage risks, and make informed decisions. This helps them offer better services and products to you, the customer. So the next time you check your financial balance or make a transaction, remember the incredible technology working behind the scenes. It's a blend of cutting-edge technology and meticulous planning, all designed to keep your financial future secure. And that's the backbone of mainframe DB2 database migration to Snowflake. A robust, reliable system that ensures your data is safe and accessible whenever you need it. Thanks for watching, and stay tuned for more insights into the world of fintech. Now, migrating a massive mainframe DB2 database, especially one dealing with retirement records, isn't a walk in the park. It's a complex, multifaceted process that requires meticulous planning, precise execution, and a deep understanding of both the source and target systems. The stakes are incredibly high, as any misstep can lead to data loss, system downtime, or even compliance violations. It's more like climbing Mount Everest with a backpack full of data. Each step must be carefully calculated, and every decision can have far-reaching consequences. The journey is fraught with challenges, but the view from the top makes it all worthwhile. You've got some serious challenges to tackle. These challenges are not just technical but also logistical and regulatory. Each aspect of the migration process needs to be managed with precision and care. First up, the sheer volume of data. The amount of data involved in such migrations can be staggering. We're talking about potentially millions of accounts, each with years of transaction history. This isn't just a simple file transfer, it's a massive undertaking that requires robust infrastructure and advanced data management techniques. Moving all that data without breaking a sweat requires some serious hardware and clever engineering. High-performance servers, optimized storage solutions, and efficient data transfer protocols are just the beginning. The entire system needs to be designed to handle the load without compromising on speed or reliability. Then there are the schema differences. Mainframe DB2 databases and Snowflake are not always structured the same way, and this can lead to significant challenges during migration. Imagine trying to fit square blocks into round holes. That's what it's like when the source and target databases have different structures. Each piece of data needs to be carefully mapped to ensure it fits perfectly into the new system. We need to make sure the data is mapped correctly, or we'll end up with a jumbled mess. This involves detailed analysis and meticulous planning to ensure that every piece of data is accurately transferred and correctly integrated into the new system. Real-time synchronization is another biggie. This is where things get really tricky. Remember, people are still relying on this system while we're migrating. The system needs to remain operational, and data needs to be continuously synchronized between the old and new systems. We can't just hit the pause button on their retirement accounts. Any downtime can lead to significant disruptions and potentially financial losses for the users. We need to keep data flowing smoothly between the old and new systems without missing a beat. This requires sophisticated synchronization mechanisms and constant monitoring to ensure data integrity and consistency. And let's not forget about compliance. Compliance is a critical aspect of any data migration, especially in the fintech sector. Retirement data is subject to strict regulations, so we need to make sure every byte is handled with care and adheres to all the rules and regulations. This involves rigorous testing and validation to ensure that the migrated data complies with all relevant standards and regulations. Finally, performance is key. The performance of the new system needs to meet or exceed that of the old system. Nobody wants a laggy retirement app, especially when they're trying to check their balance or make a transaction. The user experience needs to be seamless and responsive. We need to ensure the migrated system is just as fast, if not faster, than the old one. This involves extensive performance testing and optimization to ensure that the new system can handle the load and deliver a smooth user experience. In conclusion, migrating a massive mainframe DB2 database to Snowflake in the fintech sector is a complex and challenging process. It requires careful planning, precise execution, and a deep understanding of both the technical and regulatory aspects. But with the right approach and the right tools, it can be done successfully, ensuring a smooth transition and a seamless user experience. Moving massive amounts of financial data from a mainframe DB2 database to Snowflake is like navigating a minefield. The stakes are incredibly high, and the margin for error is razor thin. One wrong step and boom, you could be looking at catastrophic consequences that ripple through the entire organization. You're looking at some serious consequences. From financial losses to reputational damage, the fallout can be extensive and long-lasting. Let's talk about the risks involved in migrating from a mainframe DB2 database to Snowflake and how to mitigate them. Understanding these risks is the first step in developing a robust migration strategy. First and foremost, data loss is a nightmare scenario. Losing critical financial data during the migration can have severe implications, not just for the company but for its clients as well. Imagine losing even a single digit from someone's retirement savings. Not cool. The impact on individual lives can be devastating, and the trust in your organization can be irreparably damaged. That's why we need rock-solid backups and redundancy measures in place. Regularly testing these backups ensures that we can recover data quickly and efficiently if something goes wrong. Downtime is another major concern. Every minute the system is down, people can't access their accounts, and business operations come to a halt. Every minute the system is down, people can't access their accounts. This isn't just an inconvenience, it can lead to frustration and loss of trust among your customers. That's not just inconvenient, it can erode trust and even lead to financial losses. Prolonged downtime can have a cascading effect, impacting everything from customer satisfaction to the bottom line. We need to minimize downtime as much as possible with strategies like parallel processing and phase migrations. These approaches allow us to keep systems running while gradually transitioning to Snowflake. Incomplete data mapping is like playing a game of telephone. Things can get lost in translation. Miscommunication between systems can lead to data inaccuracies and inconsistencies. If data isn't mapped correctly between the mainframe DB2 and Snowflake, we'll end up with inaccuracies and inconsistencies. This can cause significant issues down the line, affecting everything from reporting to compliance. That's why rigorous data validation and testing are absolutely crucial. We need to ensure that every piece of data is accurately transferred and that the new system functions as expected. And of course, we can't forget about regulatory non-compliance. Financial data is subject to stringent regulations, and failing to meet these requirements can have severe consequences. Failing to meet regulatory requirements can result in hefty fines and damage to a company's reputation. The financial penalties can be substantial, and the reputational damage can be even more costly. We need to make sure every step of the migration process is compliant with all applicable laws and regulations. This involves meticulous planning and constant monitoring to ensure that we stay on the right side of the law. Successfully managing these risks requires a comprehensive approach. By understanding the potential pitfalls and implementing robust strategies, we can navigate the complexities of migrating from a mainframe DB2 database to Snowflake with confidence. In the end, a well-executed migration not only safeguards data, but also enhances trust and reliability. It's about turning a challenging process into an opportunity for growth and improvement.